ITI has been an educational pioneer over the past quarter century. A new course has been developed each year of the company's existence. This year, the technical services team took curriculum development to another level. This two-day course aims to educate crane and rigging managers and health and safety professionals to conduct accident investigations.
Welcome to our Woodland, Washington Training Center. ITI is proud to offer over 30 courses that improve and enhance lifting operations. Additionally, our field services team conducts numerous accident investigations each year, along with other services in our skill sets. We've built this accident investigation course with the experience and expertise in an effort to educate in-house personnel to better learn from near misses and related lifting accidents. At the end of the day, we hope to prove to you that ITI is unmatched in the world in its dedication to improving your people's knowledge and skill level in load handling activities. We hope to see you at an upcoming course.
All right, welcome everybody. Thank you so much for taking some time this morning or afternoon to invest in yourself and invest in the industry. This is Jonah Hobson, Marketing Manager here at ITI. And again, I just want to thank you for joining us today. I'm really excited about today's edition of the Showcase Webinar Series, Crane Accident Investigation, a topic that in a perfect world none of us would ever have to deal with, but unfortunately it's a reality that happens much more often than anyone would like. I want everyone on the line to be aware that student material set for today's webinar was sent out today via email. It was sent to the same email used to register for the webinar. And to really maximize your learning, it would be beneficial to have those materials available to you as you follow along. So if you've been a part of previous editions of the Showcase Webinar Series, you have an idea how these work, but I'm going to apologize in advance here because I'm going to have to cover the format a little bit for new folks that we have on the line. So if this is your first time on a Showcase webinar, I want to give you a little bit of background about ITI. At its core, ITI is an education company, training, education, consulting, really anything that betters the industry. We currently have a presence in the United States, Canada, and Brazil, companies and trainers based in all three countries, and we have the capability and have done work in Asia, Africa, the Middle East, and Europe as well. So as you can see on the slide here, ITI's expertise in cranes and rigging really applies to a number of industries. We have a pretty good cross-section of those industries on the line today, which is great because today's topic really affects any organization that participates in load handling activities. So we're really proud of this slide here. ITI has worked with some of the best companies in the world, and again, I see a number of them on the line today, as well as some new organizations that we haven't worked with before, and that, to me, is really, really exciting that they can see what ITI is all about. So the Showcase Webinar Series is a free monthly educational webinar hosted by our President and CEO, Mike Parnell. And you can see some of the previous topics are listed on the left side of the screen there. Mark out on your calendar the November edition. We're going to have a guest speaker from Terex Cranes, Klaus Meisner. He's actually the Director of Product Integrity at Terex, and that webinar should be really, really great information. So in addition to our monthly Showcase webinar, in 2014, ITI is going to be offering live online training courses. Some of the topics are displayed on the right side of your screen there, and check back at iti.com for updates in the coming weeks. It's a really exciting opportunity. So I'm going to turn it over to Mike here in a minute. Many of you on the line are familiar with Mike's work within the industry. He's the technical director here at ITI. He's responsible for developing all of the current course curriculum. Mike is also the vice chair of the American Society of Mechanical Engineers, or ASME, B30 main committee, and that committee sets the standards in the United States for cranes and rigging. He's also the chair of the ASME P30 committee, which sets the standards for lift planning. I just want to remind you guys, this is the last thing. If you have any questions that come up during the webinar presentation, please type them into the question pane there on your screen. I'll be fielding those as they come in, and then I'll make sure they get the mic at the end of the session here. So I think that's enough out of me. Mike, I'm going to send the screen your way, and then you can take it away.
Okay, Jonah, thanks very much. We'll get the screen set up here, and thanks. I hope we're coming through loud and clear. And this is the webinar document. What I want to do is welcome everybody, myself as well, Awesome Power. We have VP, CNRL. My friend Christine is hopefully online with us, and Department of Energy and Flint Energy. We have Georgia Power. Dana Morgan looks like he's registered, along with, and Dana's a member of the main committee for B30. And we've got Hanover Insurance and Hoffman Construction. We have a number of Operating Engineers Union Halls 324, 450, and 150 online with us. Some customers, JB Driver and Kimberly Clark. I see Yannick Morin is on from Craning out of Toronto. He's on the P30 committee with us. And Linkbelt. I see Mammut and Manitowoc are both here, and Navy Crane Center is here. Ontario Power Generation and PCL and Shell. Sparrows Offshore from UK. We normally have anywhere from 40 out of the 50 states represented, most of the time about 5 to 6 provinces in Canada, and upwards to 20 countries represented when they're attending these webinars. So U.S. Army Corps of Engineers, Vestas, Weatherford, Travelers. So we got a pretty nice cross-cut of folks here. On your screen, you'll see, let me bring up a couple of things that we'll want to highlight. What I'm going to be working off of is, this is the document. This is a 46-page document that you were emailed. So it's probably best and easiest to download this document if you haven't already, and then print. And then what we'll do is track right along using this document from the introduction to the accident all the way through the evaluation and some of the potentially root cause analysis and some of the violations that might have been incurred here. So if you have this document, this is the one I'm going to be working from. I'm breaking out from a PowerPoint over to this live document, and I'll be making notes along the way as we progress. So get this document in front of you. It's 46 pages, and we'll get ready to start on that. What you'll notice on page 3 of the document, there are a host of exhibits, and those exhibits are numbered 1 through 15 out of the 46 pages. And towards the conclusion of the document, the last 12 pages, we have 8 of them are accident investigation document items. And then we have 3 root cause analysis, and we have the last one is the violations page. So those are all included in this 46-pager. We use these regularly. Actually, I have to fly out to Minnesota today. It's afternoon to a crane accident at a church. They rolled over a crane and dropped a double T-beam. It's about a 25-ton concrete structure. So basically, I'll be using the same document as we go forward as far as the 8-page accident investigation, and then eventually in this case, we're leading into the root cause analysis and violations. Now let's open this up to page, what we'll call page 4 in the document, and you'll notice it gives a description of a narrative of what happened with this. We'll notice the date is February 18th of this year and 1:50 p.m. And the fatal is a gentleman named Jimmy Swenson. And he was assigned to move a cutter head, which is a dredge component, move that in the yard. And they are at a dredge company facility. That's this is the group, Harrington Dredge Company. and they have been in business since '58. They recently hired John Gagne is the, or Gagne, is, depending on where you're from. John is he is the safety director, but newly hired about 2.5 months or so before this incident. So he's new on board, and so as you read down through the document, what I need to let you know is this is an outtake of a normal 2-day course that we do in Woodland, and so we're going to run through this fairly quickly. So I need to provide you some information. The safety manual that Harrington has opted to use was, and you can make some notes on your documents there, it's an internet version of a safety manual, and there are 0 instructions concerning crane and rigging activities, load handling activities. So they have no current in-house publication for crane and rigging procedures. So they have a light-duty manual. Gagne is the safety director, and he's trying to upgrade that, and he's a bit swimming against the current right now in his oversight with the organization. And I'll show you a couple things that he's captured downstream from employee data and so on. So let's take a look. Let's go over to the next page. This is the sheriff's report. I'm going to bounce this up on the screen. This should be very similar to the document that you have. What we did is we went into, and we've had to move this to a nondescript city in Carolina, South Carolina. But by pulling up the, and we just did this for the accident this week, we're able to go on to a couple of websites and identify wind speed and temperature. We noted in this one, if you want to make a note, please, we have 5 miles an hour westerly winds, and the temperature is 50 degrees Fahrenheit. So you can make those recordings. And those are things that may not be immediately available on like a sheriff or police report or some other report that's been provided to you as you conduct an accident investigation. But you'll want to eventually capture those. They may have definitely an impact on the evaluation that you're conducting. So let's highlight. What I'm going to do is highlight some things down through here with you, and then we're going to tabulate them back in the accident investigation form eventually towards the back. So let's highlight a couple of things. Obviously, we know the date and the time. The accident may have been certainly a few minutes before that. The calls came in pretty quickly. For Mr. Swenson, the fatal date of birth, 3/5/91. He's, at this point, he's 21, 22 years old, very close, and by narrative by the Sheriff's Department, the operator was ejected during the crane tip over. So this narrative is right down in the body and starts here, and we're going to take us over to the next page, and that's what he found on site when he showed up. It was deceased, no pulse, no breathing, and the medics were called, EMTs were called. The narrative continues from the sheriff's report, and I'm going to highlight these as we go because these are things that are going to be important to us downstream. Certainly we have a crane tip over, suffered fatal injuries, and the location is the Harrington Dredge Company's primary yard. There are some witness accounts, and we'll see these later in the document. So we have some witness accounts from the folks that are noted here. And one thing that was told to the sheriff representative when he was on site, and notice that Swenson was an operator in training and was assigned to move a large steel cutter head. And the notice that says here, based on the interviews immediately by the sheriff's representative, Mr. Swenson, he moved the crane next to the cutter head. He picked the cutter head up, and he swung the crane boom and load to his right, and the crane tipped over. and Mr. Swenson was ejected out. And the crane accident involved a Grove TMS 180. It's an 18-ton unit, and there's a serial number built in 1972. So there's some data here we're highlighting that we're going to carry over into the ACTS investigation. Now, what I've done is prepared for you you have a whole series of contact prints that are numbered, and they're results of 3 different cameras taking shots, and they've been compiled. What I'm going to do is I've combined these into a bit of an easier, I broke them down to 35 pictures out of the 150 or so that are collected. So let's take a walk through those pictures, and I'm going to put up the most significant pictures and tell you why I've highlighted these and brought these forward for this presentation. In this one, you can see that the crane is down. The load is there. The load is turned over. This is the cutter head in question right here. And, of course, the hoist ropes are, and we'll identify what those, how many parts align and so on. And then the rigging is identified, and you can see the rigging is there. So, and then the crane boom, of course, is laid down across the yard, and it is actually buckled right here as it overturned. So let's take, so I'm going to kind of walk through a photo set for you to give you an idea of the different elements. These are coming right off the contact sheets that you have in the PDF document, both in the crane section and the rigging section. So let's take a look at number 2. And this is just a front-on view from the boom tip right up here towards us on the lower right. And the boom's laid down, it's buckled right here, and then it goes up to the machine, of course, and we have the crane is on its side. Nothing miraculous there. This is a mannequin that actually represents Mr. Swenson. There's broken glass down here on the ground, and that glass came from the side window to the operator's right. He was ejected through that side window, right through the side window here and onto the ground, and suffered fatal injuries. Okay, let's take a look then at the next one. This shot was taken to help us get an idea of what the outriggers were doing and how the crane was set up. Notice that there are there's no blocking or crane mats underneath these outriggers. These 2 outriggers on the ground side, on the basically it's left rear, left front are seen in view here, and then the right rear, right front are out of view. So these were set here and here, and there's tape measures there to their approximate location when the crane was upright. And let's take a closer look at that. And one thing I want to remind you of as you kind of conduct a ACTS investigation is the thinking is, of course, is to take large shots, medium shots, and then close-ups, so that it walks you up to the evidence. It takes you, it gives you perspective, and in series, outside, middle, and inside close-up shots, so that you have a better perspective of what, because it's a year, 2, and 5 years later that this may actually come to court and things are happening. So you'll want to kind of track your pictures in this method, and though I've kind of clipped these shots together this morning, you'll want to get a perspective of what am I looking at, why is it important, make notes, and what the evidence is telling us. So we'll go to the next one here. The reason, if you'll notice, there's a depression in the ground right here, and I'll just draw an exaggerated swell there, and it's hard to see this one back here, but there's a swell back there. And you'll notice, we'll get one up, one closer, and notice that if I used a hard straight edge, we could see it, you know, starts here, comes down, and ends up, the shadow is right there. So this is all depressed ground, sunken ground, and we have indentation of where the outrigger was sitting, the float was sitting. Something to note when we're going to make a remark that it appears, appears to be sinking ground or collapsing slightly underneath the outrigger. So something to make note of. It's going to need to be incorporated into the accident investigation documentation. This particular picture, and I apologize for the out versus in. However, I will note that if you'll note this, I went back to second frame here. Note this knuckle right here, right by the cab window. That is the boom heel pin, well, cylinder pin, and I want you to see where we're going to take you up to the heel pin location, and we have 51 feet of boom extended. So that's the boom heel pin and 51 feet. So looking back, we have then from there to there, from center pin of sheave to heel pin, we're going to make a notation of 51 feet. That's why that note is important to us. All right, so then we've got a perspective here of outrigger position, radius, and boom point elevation. I made some notes to myself, so if you take a look, right down here in the lower right, let me bounce this up just a bit and get this into view. And what we're looking at right here, we've taken a tape measure straight away from the outrigger, and the center rotation is, I believe, 7 feet from that outrigger position to center rotation there. Make a note there. So we have 7 feet there, and then we continue out to try to find out what was the approximate radius. So we've taken a tape down from the boom point and a tape out from the center rotation to find out two things. We want to know what's the radius and what's the boom point elevation at the time, approximately at the time of the accident. So we're starting to run tape measures here to try to get some of that data. So here we'll see the intersect, and then we'll get a close-up of that. So if you'd like to make a note, please do so. The boom point elevation, that's coming down this direction. We're going to call that 56 feet. That's 56 foot 6. So as it comes down, there's the intersect mark for that. So it's about 56 feet boom point elevation. And radius coming out from the crane, here's 29, and we're up to about 29.7 or so, and we have an approximate 30-foot radius. So we need to make those notations as well. So let me back out of that just a bit. And so we've got some data starting to be collected here, some recording. And this is a wide shot to help give us perspective. So we've got our radius noted, and we've got our boom point elevation, and then we have our boom length. So this is 51 feet, 56 feet, and 30 feet. And we'll have the load chart. It's already incorporated into your document package, but we've got some data on its physical setup. Let's continue on, and let's take a look. Now we're going to walk down the boom, and this is the center pin of the sheave, and measurements are made from heel pin to center pin or center pin of sheave down for hoist lines. So center pin of sheave really is our key starting point. And then we're going to walk down the boom. This boom has been spray painted marked for footage for extension. So we'll see here's 34 feet, 40 feet, 46 feet, and so on. Walk down the boom, here's 52 and 58. But all of a sudden we get to this intermediate section. So this is the outer boom section, and this is the intermediate section, and this is the base in the yellow. So what we're seeing right here, we're seeing a intermediate section that's only extended that far. And so we have about 4 feet or so, 3 feet of that intermediate section that's extended, And on this particular crane, we'll make a notation that these boom sections are unequally telescoped. On this type of crane, we'll find in the documentation by the manufacturer that they should be equally telescoped. In this case, the operator did not. You'll notice if you take a hard look right in here, you'll see a little 3. And I think you're going to find that that 3, if we were able to pull that out, that 3, I believe, will end up matching with this 3 that's on the outer. So when they're both telescoped equally, at that mark and back at the intermediate mark, when they're equally telescoped, it will be at 34 feet. Another section comes out, another, both equally telescoped, 40 foot's going to be showing up, then 46 feet, and so on. So we've got a boom that's not equally telescoped. It did, you know, what would typically happen in a gross overload if this was fully retracted all the way back in, we might have had a failure right here just from structural failure. That didn't happen here, but it could have easily happened, and it has happened on a number of cranes where you have that smaller outer section extended, the intermediates are retracted, and we end up with a failure there. That wasn't the case here, but if you had broken the boom, we'd seen the boom broken there, you know, it starts to tell a lot about what the operator setup was and the condition at the moment of failure. Let's go on. We're going to take a look. We had a large picture of the crane block. This is a McKissick block, part of the Crosby group, and it is and I'm going to bounce this up for us so we can have a little better data read on it. So let's please make a note there on your document. This block weight right here is 520 pounds. The tonnage capacity, this is a 20-ton block, and the rope diameter is set up for 5/8-inch wire rope. And of course, the 4-to-1 design factors there. We have the model number, serial number of the block, and so on. So this block is, we have data that we need to capture on this. I hope you're capturing it with me. 5/8 setup for 5/8 rope. 520-pound tear weight for the block, and then 20-ton capacity for the block. So let me bounce back a couple of page magnifications here. Let's go to the next photo. And sorry about the little bit of a disturbance here with our little shaky there. 0.511 diameter, and this rope is, we can tell when we made the evaluation that it's 19 by 7 compacted strand, and it is actually 1/2 inch. So you'll remember from the block dimension, block information, the block is set up for 5/8 sheaves, and the rope is 1/2 inch. So we have a mismatch right there. Somebody grabbed that block to put on the crane, may have been used for another crane, and they're running 1/2 inch rope into a 5/8 sheave system for a block. So the rope is slightly oversized, and that's acceptable up to 5%. So we're just confirming what rope did they have in place, did it match the load chart, did it match the manufacturer's requirements, and what block and sheave sizes should be used. And now we already notice we have incongruity in the equipment assembly. This is a fall distance perspective, and what we've done is taken a tape measure from the center sheave pin down to the hook to see the approximate length of fall for the hoist lines. It is a 4-part system, and we'll find in just a little bit the capacity of that supporting system for 4 parts of 1/2 inch line. And then we've got the rigging there and then the load. So let's see where our tape measure ends up, and I can see 20 feet right here and coming down to about 21, and we know our rope is slack laying on the ground, and we're so it would be sufficient to say it's plus or minus very close to 21 foot fall distance. And then we have the rigging to deal with and the load to deal with. So we've got 21 foot of fall there. There's our load. That's a cutter head, goes on a dredge. And you can see some slings rigged there. The load weight is, we'll find out in our data, is 13,800 pounds. So let's make that recording as well. I'll take you to the documents. Well, I stuck a tape measure through the load and measured it from bottom to top if it were sitting vertically. And what we found is the load's about 6 feet tall, or within an inch or so. And so we're starting to get some ideas of its overall elevation. Then let's take a look. Oh, we've got another shot. We've taken some big shots. Now we have a close-up. Kind of take a note here with me, if you would. A couple of things that are really odd about this setup. Notice the wedge socket right up here. Here's the live line. And the live line is entering into that wedge socket on the away side or non-pin side. So it's moving around, and then the tail, the dead end, is coming out. And we all know that the live end should actually be entering right into the alignment with that pin right there. So this is backwards. This is the setup for this wedge socket is backwards. Sorry about that. We'll get this back in order here. And we have to be able to also identify on the A2B, the anti-2 block device. Take a look at that. And notice that the weight is hanging down here. It's circling the rope. And there's a dog leg right there. Whether that was before or after the accident, we're not quite sure. But notice that the weight chain, let me get rid of some of this information here, kind of get rid of these scribblies, and take a look at the weight chain. And so that suspended weight for the A2B anti-2 block is going up. It's actually looping through just a shackle right there. It's not really connected to the sensor device. So this anti-2 block device is improperly connected and should have been connected to the A2B sensor device, that by lightening that weight up, it would trip a sensor and stop hoisting, stop extension, or stop booming down. So it's just simply there for show, and it's really not doing anything. It's just hanging on a shackle. That shackle is just simply rigged to a pad eye right on the crane and not doing a thing for us. So we have an improper setup for our crane and our hoisting line, and our anti-2 block is it's just for pretty. It's not for function. So let's take a look at the next photo. I'm going to back this out a little bit. Notice that this particular photo is showing the outrigger, and this is the left side outrigger set. And so the left side outrigger set is extended 24 inches. So we're right down here to about 24 inches for extension for that left side outrigger. So this is left side, which is the fall side. And then let's take a look at the next one. And the upper, this is the right side, right front, right rear. And that's up in the air overhead. And let me bring this down into view. And we're showing, I'm going to bounce this up just a little bit for magnification. And we're showing, we've got 2 feet, 3 feet. Here's our 4-foot mark, and we're at 44 inches of extension in the air on the right side. And so we have, and that's about all that crane will do for full extension after we review some documents. That's about full extension for that particular outrigger. So we have 44 on the away side and 24 inches on the fall side. Let's take a look then also at the load itself. And notice that we've got 3 choker hitches. These are web slings, synthetic webbing slings. And we have a choker hitch right here. There are 6 actually. Let's count them up. I'll back that out. I got 1, 2, 3, 4, 5, 6 arms on the load. And what was done was that the operator, Jim Swinson, rigged to every other one with 3 web sling choker hitches. So we have 1 right there, skip 1, 1 right there, skip 1, and 1 right there. So he's put 3 choker hitches at 3 points on the load, attempting to equalize the loading on the 3 slings. They basically run right up into against the center housing there, and they're choked. Those are all fairly round, smooth surfaces. And well, now we're going to go into a little bit more on the slings and their condition and their method of rigging and their condition. So around the cutter head for connection point, I just sent the tape around and made a big loop and went around the connection point, and it was about 3 feet, a couple inches over, depending on how tight I want to pull the tape and how tight I want to pull the sling. So we have about 3 feet around, and I made a note off to the side here. So plus or minus 3 feet around, and the slings are 12 feet in length, and that left us a 9 foot remaining. So let's see what we've got so far. I'm just going to, on this page or the next one, just make a side note if you would. Let's kind of tabulate what we know so far. So the crane is set up, and this is all to scale, of course, everybody can tell that. So the crane's set up, and we have an estimated 21 feet of fall distance, 4 parts aligned. We've got the block, that's down to that hook. The rigging was set up, and we have about 9 feet of slings from the top of the cutter head up to the hook, and then the cutter head height is 6 feet. All right. So let's just add those up very quickly and see where we're at for suspended load height. So I've got 21, 9, I've got 36 feet from boom point elevation, boom point to the bottom end of the load. And if you recall, what was our overall boom point elevation from our previous evaluation, and if we take this out here, and it was, if you recall, 56 feet. Okay. All right, so I've got 56 feet overall and 36 feet is suspended, and we're basically 20 foot off the ground for our load suspended. When we go looking at the documents, we're going to identify there may have been really no good reason to lift the load that high off the ground, but the base of the load is 20 feet up off the ground, and the operator was working by himself, no riggers, no signal person, and the load's 20 foot high. So just as a notation, just something to kind of keep in mind. All right, so let's take a look. This is Sling 1, and there are actually 2 different manufacturers of the 3 slings. DCL, they've got their label on this particular sling. That's a rigging shop in Louisiana and south down in the Gulf area. This particular sling's made its way to the Carolinas and been sold there. The choker hitch capacity is 4960, something of interest to us. So if we take 13,000, just kind of as a quick estimation here, 13,800 for suspended load. Let's do a quick calculation and see what we have for, and I'll hit this in. And so I've divided by 3. If we were evenly loaded, would be about 4,600 pounds, and we have a slight angle there. If you actually do the math and take a look at the length, height, and run, you'll find out the multiplier is less than 1.1 or 1.01 times share of load. So we're in the 46 range or something like that for actual tension. So it is this sling actually passes for capacity, but we need to look at its condition as well. And as we made the evaluation on this sling, even though the crane tipped over, I want to always make sure to be able to answer for what was the condition of all the equipment, all the gear, all the rigging, all the shackles, the block. Do the whole works. Do sheave inspections. Do condition of point sheaves, condition of block sheaves, condition of hooks. We would have made all those measurements because we want to understand the overall integrity and quality of the equipment used. So even though the slings didn't fail, we're going to continue to make sure that we understand their condition and be able to report to the client and or to the court the condition of all equipment and potentially any measurements necessary and so on. So we start to take a look at this particular sling, and we laid it out on top of the boom and started walking down and made some notations. And this looks like old damage on that sling right there. And we have, it's dirty, it's grungy, and the damage is not new. It's not, I'm sorry, it's not fresh. So basically we have this sling is in a rejectable state prior to use. So we've got damaged rigging already being used in the rigging, in the crane accident. And I think what we'll find is in each case, we're going to find something wrong. This is another DCL sling. This is the second sling, sling number 2. If you're tracking with me, and then the choker hitch capacity, this is a 3-inch 2-ply sling. It's a little bigger, and it's got 13,120. And our anticipated tension was just over 4,600 pounds, something in that neighborhood, and based on the angle. And from a capacity standpoint, that sling would have been okay. However, as we do the inspection, lay that sling out on the boom, start to look at it immediately, we start to see damage here. Again, that looks like old damage, not new damage. You just got to make the call on site and make the decision. And further down the body of the sling, you'll notice a very large rupture there, puncture, and some what appears to be very hard surface melting along the surface there, but that looks old as well. So really this sling was in a rejectable state as well, though it was used in the accident. The third sling has a different tag on it, and we've laid it out for us to take a look at. I'll bounce that up, but I do want us to note before we change from this picture, we've got some cutting across. This is the splice area, and so we have some cutting going across there. That doesn't look new either. The fibers are worn. They look bleached a bit, dirty, and it does not look like a fresh type of damage. So I would suggest that this sling is also rejectable based on its condition, and let's get some information about it as well. It's the company purchased this, Olympic Synthetic Products, and then take a note down here, choker hitch 4,000 pounds. So we've got an approximate sling tension of 4,600 pounds, and we're down here using a sling at 4,000 pounds. And basically, we have an overload condition, the sides being damaged. So nothing's going right for this. We're overloading the sling as well as using it in a damaged state. So our rigging really doesn't fare well. But what it does, it speaks to the lack of professionalism. Would we not question, off to the side, question training or knowledge of rigging inspection? And in this case, it would have been Jimmy Swenson, the operator, who rigged his own load. And so we've got damaged rigging, and we're overloaded on one sling. We're in a big pile of hurt here. So we've got a situation happening that's not very comfortable. Now I'm going to break away from the photo set. So let's take this away. Now we're into your photo set that you have. We're on page 8, page 9, page 10, and we've evaluated those. Let's take a look at page 11 in your document. And this was provided by the site folks. And so I'm going to point out, let's point out some different things and circle or highlight some different elements here that strike us as odd or strike us as conditions that may have contributed to this. So let's see. Notice even in the drawing, we've got short outriggers on the crane's left side and long outriggers on the crane's right side. So we really don't have fully 100% extension. And I'll make a note there, no 100% extension, and there's no, and I'm cheating ahead, but there's no chart for 50% or less. So this crane, 1972 crane, does not have an older chart or a chart that gets down into the 50% or 0% extension range. It's only got a 100% extension chart, and so because of this, if you'll notice right beside the crane, the operator was warned that there is an underground utility line right here, and he knows that, and he's been told by management that line is basically a sewer line, and it's not very deep, and he was told not to put his outriggers on that. So we've got a problem there, and he appreciated that. And notice where he had to take the load from and to. So the pickup point for the load, we'll just make a highlight right here. Here's the pickup point for the load, and the set down point was right here. They needed access to this area back here for some work activity. So they were trying to clear the cutter head out of the way so that they could gain access back there. Now at 30-foot radius from here to center rotation, if that's 30 feet, it's possible that he could have reoriented the crane over, we'll go arc this way for a minute, reoriented the crane so that he could possibly have straddled that, that utility area and set the crane up such that he would not have been on top of that. So it's possible to do that. He could have possibly repositioned and still maintained. And at 30 feet, he was actually, we'll see in a minute, but that was actually, radius was greater than his capacity. So likely would have needed to be in there. Could he have done it at 20 feet, set up at 20 feet, or possibly at 25 feet? That's a question mark we want to look at in the evidence as we go into the load chart. So we've got ground limitations that impacted his setup decisions, and they've all led to a fatality. And as we continue to do the investigation and evaluation, let's go to the page 12. And on this page, we have been provided a shipping ticket. This is Exhibit 5, and this helps us confirm the cutter head is 13,800, and that's been provided by the company. Let's go to the next page, page 13. Waylon Simmons is one of the yard foremen. He provided this sketch or schematic of the rigging method. And so we already know by our pictures and photographs, we knew we had 3 choker hitches, 3 web slings. Pick points on the load are as they appeared. And then, of course, then we have the 13,800-pound cutter head confirmed down there as well. So that's Exhibit 6. Let's go to Exhibit 7, which we've already evaluated that photo set. We'll bounce through those. And let's go to one of the first statements here then by one of the employees. Let's take a statement or a statement by a gentleman named Cletus Riley. So this is the These are taken by Mr. Gagne after the accident as he interviewed different folks and asked them to make a narrative of what they saw and or what their activity was involved in this lift. So Mr. Riley is the yard manager, and he says, I told Jimmy to move the cutter head about 30 feet from where it was and get it out of the way. We needed to put the crane there to move some other things. He said, I told him to avoid the sewer line that was runs under a couple of manholes. So he provided some direction as to where to set the crane. The cutter head needed to be moved about 30 feet, but Mr. Swenson moved the crane just up to the east and west type orientation of the sewer line and along the west side as well. So he had directions from Mr. Riley on what the job task was and what needed to be done with it, and to be wary or to be aware of the sewer lines that were there. Let's take a look at the next one. And this one is Exhibit 9. And this is a gentleman named Bill Urquhart. And he said, Jimmy's boom, he noted, and I was in a crane loading out a truck. So he's an operator. And he looked over and noticed that Jimmy Swenson's boom was not scoped out properly. And he wanted to talk to him about that. He saw him getting light as he just barely started to initiate and swing over the side. And then he started to yell to try to get his attention, but it was too late. So he noted the improper crane setup for the boom, and for the unequal telescoping of sections, and he noted that from afar. And then he was going to try to get a hold of him and talk with him about it, and then he noticed immediately the crane was getting light and it went over. All right, so that's Mr. Urquhart. The next one is from John Gagne, and that is the safety representative. There's something screwy that happened with this crane. The in-office field paperwork information notes that this crane is actually, this serial number is 2965 in the office. And what they found out when they went out to the crane, that after investigation, note right down here under load chart, they had reinstalled crane load chart in the cab, salvaged from a similar TM180, and that serial number was 2965. So note 2926 versus 2965. What we don't know is, did they evaluate the crane, confirm with Grove that they were set up exactly the same with exactly the same counterweight? We don't know that yet. That would be something we'd want to evaluate and investigate. But one load chart was walked from one crane to. So and this isn't unusual. It does happen, and it's something to be very wary of, to make sure that the serial number on the crane itself matches the serial number that's on the load chart in the machine and in all paperwork. It can happen that they get one that's a replacement, but the serial numbers should match based on the crane setup, configuration, and final assembly by the manufacturer. On the next page for Mr. Gagne's report, and I'm highlighting some areas that you can read, and you are reading there, but notice down here that crane operator Mr. Swenson, in-house training by Lance Minion, who's a yard operator. He had some training, has been making lifts on his own, has been warned in past regarding proper placement and use of outriggers. So this has already been a discussion point that has been exchanged with Swenson and other personnel. And then based on setup and so on, sometimes being light in the back, outriggers. So, and that also would indicate, so we've got two things kind of happening here. And improper setup of outriggers, and getting light in the back would be potentially overloading the crane by extended radius. Because when we get light in the back, it basically to the back outriggers to the operator would be his away side, to the front of the truck base. He's really reaching too far. So kind of a couple things. Not always setting the crane up right, and always willing to challenge the crane for its lift capability, and so on. So we have a little bit of history here that should be taken into account. Let's take a look at the next page on Johnny Scott's not deposition, but his witness account. What I highlighted here is he was it's a forklift operator and heading to the shop, and he says he noticed that Jimmy Swenson didn't really seem to have control of the load because it was swinging. So we have some reaction of the load during the load handling activity. He said, I noticed Lance was running towards the crane, waving his hands, yelling for Jimmy to stop. So a couple of things there is machine control may be a question. It may be simply that it was in the middle of its tip-over activity, but there could be question marks. We have an evidence by witness account that we have some unusual dynamic movement of the load, but we also have Lance was one of his guys who was senior operator was running, and that tells me is there's no direct supervision that helped plan the load move and plan the load handling activity. And when we get back to the qualification sections, we'll notice that Mr. Swenson was trained but not qualified for small hydraulic cranes. So he's really, and even the sheriff's report noted that he was an operator in training, not really a fully qualified operator. So if Mr. Minion was running to and waving his hands and telling Jimmy to stop, he really wasn't there beside the operator, beside the crane, making double checks on the crane capacity and load chart and load weight, et cetera, and radius. So we really likely, I mean, when you start adding all these up, you're going to get down to, gee, we don't have direct supervision happening for an operator in training. All right, let's take a look at the next short witness account. And this is a young guy that was taking lubrication and so on. The next thing I heard Lance yelling and screaming, and he's just simply an observation. He ran. He turned to see Jimmy's crane tipping over and Jimmy being shot out of the cab. So he confirms the witness account prior to that. Lance was running over to the crane, and we know that's again lack of supervision. That kind of confirms that. Here's something very interesting on page 24 in your document. Let's take a look at that. This is a compilation. Notice right at the bottom down there, there's a note. And what that note really indicates to us is that, note, training dates and qualification have been gathered over time based on in-house training activities as the employees have been deemed qualified by Harrington Dredge Company management. Revised, John Gagney, December 14th, 2012. So what John did was collect and interview the employees and try to look for any kind of documents that would help confirm their qualification and or training. Notice in your document that you have in hand there, we've got a line item here for Swenson. So let's kind of highlight that. Here's Swenson right here. Now let's highlight where he's qualified. And so we've got this column and this one, these two out here. So let's take a look and see. I'll bounce this magnification up. And so let's see what we have going on there. So this one is, he's a yard laborer, trained, and he's a trained deckhand. And then over in this category, he's trained for small hydraulic crane, less than 25 ton, but he's not qualified. That box is empty right there. And then the last one over, he's a qualified mobile crane signal person. So this one really, and it was, as noted by the sheriff investigator, he was an operator in training. That pretty much tells the story right there. He had some training, should have been under direct supervision. He was actually operating a live load and without any supervision and not qualified. So it starts to tell the tale about the organization's operation and about how they manage their employees. So those are all evidence items that you know, we're not creating anything, we're just noting everything. And what we can't do in an investigation is make gross assumptions and start down a bunny trail and decide that, on our own things that are not supportable by evidence. All we can do is really let the evidence tell the tale and you know, stand firmly on the evidence that's there, and then let that lead us to some conclusions as we progress. The next page 25 is the exhibit 14, and you'll see that that is a manufacturer's description out of their operator's manual for the crane and some of the drawings, some of the measurements there. Page 25, 26, 27, and these are operating configuration specifications for the boom based on which type of machine was purchased by the customer, boom nose, boom point elevation, or boom elevation, jib. There is a jib for this crane. It was not used. It was not attached to the machine. Swing information and cab and outrigger control and so on. None of this really jumped out at me in the evaluation, but let's take a look at this one. And under page 27, we have some different pieces of information there. I'm going to mark the drum. Get that highlighted there. So drum rope, and it can contain for the main hoist 720 feet a half inch. And in this case, they had 19 by 7 compacted strand. Line pull for a single part line was 6,150 pounds per part of line. That was 19 by 7 compacted strand. So when we take that information, and we've already measured the rope. We know that that was half inch, and it was 19 by 7. We've made an evaluation of that. Compacted strand was going to be slightly higher than standard rope. But let's take a look at the line pull capacity based on the load chart. I've got 6,150 per part of line times, we had 4 parts of line in that system, so we had a reeving capacity of 24,600. And so we had a reeving is the catchphrase for a number of parts of line, and its reeving or lacing method, etc., how its rope is laced into the block. So we had a gross capacity of 24,600 for the hoist system. And if you remember, the block was 20-ton block, 40,000 pounds. So from a structural capacity standpoint, neither one of those really, in this case, was compromised. The hoist rope parts of line nor the block were compromised. We just have to make a double check and be able to prepare that and present that in our findings. Nothing jumped out at me here, and probably to any of us, about the speed and gradability performance or axle weights. So on page 28, it's nice to know, but not a counter on our action investigation. And finally, we get to the load chart for the crane, and then we have a range diagram in just a minute. So let's note some things on here. I'll bounce this up on the screen just a little bit. And notice that the operator, Mr. Swenson, was working off the rear, and then he swung to his right, which would be the machine's left, in effect. But so let's do this. we'll go back up to let's go back up to one of the previous exhibits here real quick, and let's go up to let's go back to page 11 for a minute. I'm on page 29, so let's take a look at page 11. This is the setup as identified by Mr. Simmons. I'll bounce that out a little bit. So we'll notice that we're working dead off the rear of the crane, dead off the rear. Here's the front of the lower. We're working off the rear section, and we're working off of this quadrant, off the rear quadrant right in here. And then the operator was attempting to move the load to his right, to the machine's left, and trying to enter into what we call is the side quadrant. So going from rear to side, all right, and the crane laid over. So let's go back to page 29. He was in the rear quadrant and moving to the side quadrant when the accident took place. So from the rear quadrant, let's take our information that we have based on our measurements, and let's make some notations here. And we had a radius that we've measured out to be right about 30 feet. This is the over the rear chart, and I'll take you down to the over the side chart in just a minute. So over the rear chart, and if you remember the boom length, it was actually more than 46, and actually right into the 52-foot range here. It was at or less than 52 feet. I think we measured 51. So when we bring those down and intersect those, bring this across, and we find out that our gross capacity was 12,200 pounds. And so we're going to note that for our investigation. Off the rear, the crane's gross capacity was 12,200. We're going to get a gross capacity in just a few minutes as we go to our investigation form. Over the side, that's the over the side chart, is this next chart right down here. And if we again use the 52-foot boom length and the 30-foot radius, we're going to come in to find that we had a gross capacity of 10,200. So let's note that, and we're going to carry that forward into our investigation form. One last note while we're on this page, on page 29, are the fine notes down below. And what we've opted to do, of course, we're going to need to add all of the information up for gross suspended load. And item number 4 talks about the weights of all load handling devices. It doesn't specifically say we need to add the wire rope in this case, but we will. So we're going to be adding, what we're going to be actually noting will be wire rope, eventually in our form coming up. We're going to add the block weight. We're going to add for slings, and we're going to add for payload. And so those 4 items will actually end up accounting for all load handling devices and suspended load to be compared to our load chart. One other item of interest right down here at item 10, if you'll notice that with me, I'd appreciate it. So let's take a look at item 10 and see what the instructions from Grove were. And it says that all power telescoping boom sections should be extended equally at all times. Do not operate one fully extended and another fully retracted. Okay? So we know the crane was not set up properly. Grove even gives a good guidance or requirement as to what they're supposed to do and be able to use. By the way, notice it says in here single line pull is 6,000 pounds with the load chart data back that we had. So at least we were at times 4 again. We're at 24,000 for reeving. Okay. All right. So let's go on. And oh, by the way, on this particular page, on page 29, notice right here in the right-hand side, this is the load chart for the crane serial number 2926. So this was used for the crane, and I believe it was 2965. and we're not sure if anybody confirmed that it was exactly the same configuration, counterweight, boom sections, all that, and it was confirmed. It may have been exact replication. We're not sure, but we're getting some mixed signals here from the load chart that's here versus the actual serial number on the crane. So that presents a challenge for us. Page 30 shows us, and we're just about done with our investigation data, but page 30 shows us the approximate configuration of the crane when it was, when it ended up laying over. It could have been a foot or two difference in boom length, a foot or two difference in boom and radius, but in the as-is condition, we're out here at 30 feet, and we're up to about 56 foot, and I think we're at about 55 degrees. Right in here was our elevation. So 56 foot of boom point elevation, and so our boom was set up about in this position during the operation. So it's just a little bit nice to know what was the range diagram provides us that data. This is only a help or an aid to the operator. It's not really super helpful to, you can help get, this can help us understand a little bit more about upper elevation lifts and clearances and so on, but this is just a double check, and this just gives us an idea of the boom configuration during the time of the accident. Let's take a quick look then at the inspection form for this crane, which was done, and we won't spend too much on this. However, this was performed about 20 days before the accident, so we know the condition of the crane. They also noted that it was 2926. They went off the load chart serial number, and that's how they recorded it. And we can flip to the next page there on page 32. They noted that the crane was in reasonable condition, fire extinguisher kept inside, so that was a notation. Notice on the deficiencies, no certification deficiencies were found. However, on the last page, something of interest to us is, and I'll bounce this up a little bit, that the outrigger's box beam inside facing the hydraulic hose access is fractured approximately 1/4 inch, and the instruction from the inspector was to monitor and then repair during next PM for this machine. So it was not a tag out condition, but they noticed a small crack or fracture. The same basic note is made in item 2. There's a small fracture and a corner weld on the doubler plate. Again, the instruction from the inspection group was monitor and repair if needed. So these apparently in the inspector's minds didn't cause the shutdown of the crane, certainly an older crane, but they made notations of it, and I would have hoped that they would have checked with Grove to see, or Grove Repair Center, to see if these conditions would have been cause for stopping or tagging the crane out of service. But in this case, the inspector who signed the document made notation to monitor and repair. All right, very good. Let's go into our investigation form here, and I'm going to make notes across the way here as we go. And I'm going to pass just quickly on some of the data that we have here. We're going to, I'll just make some notes here. We have an address, phone numbers, and so on. The company is HDC, and we're not going to detail out each one of these items. Mr. Gagne was our point of contact, and we have phone numbers and so on. So what we're going to note down here on the form is the date of the accident was 2/18/2013 at 1:50 p.m. or so, and then the address was HDC's yard. And of course, then the description of it is the crane overturned, and you should be making notes along the way. And the crane, and then fatal. So that's a narrative of, okay, what happened. quickly, what are the short ends? Now let's go over to the next page. So if you're using a form like this, these are the things that we're going to draw all of our information forward. I'm going to bounce this up a bit so we can get this in view. Sorry about that. And this is a LHE page. What kind of load handling equipment is this, and speaking to, and what should we be noting here in our form? So we're going to check this box off over here on mobile crane, and we're going to denote it's a Grove TM180, and we have two serial numbers, is the 2926 and 2965, and then part of that comes from, and what I just note out here is Exhibit 2, and that's from the Sheriff's Report. So I try to make some notes sometimes. Where did I get that information? Where do I need to arrive at that data? And then we have 4-part reading, because this is the condition of the equipment at the time. We found anywhere from 6,000 on the load chart to published 6150 on the load chart. And so that gives us anywhere from 24,000 to 24,600 based on the manufacturer's information. Typically what we're going to use is the published data on that chart would be 6,000 and 24,000. That came to us from and Exhibit 15, which is Exhibit 14 is the load chart, so we have that data captured. Crane block. So we're making notes along here. These are conditions of equipment, description, all the details that you need to final and bring into this particular document. Crane block, it's 5/8 rope, 20 tons block. We do have a serial number for it. It weighs 520 pounds. And then we come down a boom, 51 feet, and not equally telescoped. We're going to make that notation. And that was also from a photo, and the information also provided to us by requiring equally telescope sections came from Exhibit 14. So I make that note to capture that. That was on page 29. So I can always go back quickly and refer to it. Where did I get that data, and where can I get that information again? Radius, we have equaling 29'7" or 30 feet. And then that was based on a photo. And then we've got operator information. Let me see. I'm going to put down here wedge socket first, and we'll be running out of room here pretty quick. But wedge socket was the right size, but improperly applied. And making notes along the way, and then that was from a photo. I have that captured. We have an anti-2-block device that is improperly applied, and then via photo. Okay. All right. Then another condition that I noted was short outriggers. That's from Exhibit 4, which is the drawing, and then photos showing 24-inch extension on the short side versus 44-inch on the long side. And then a little bit about the operator here. Because in tying him to the LHE, let's see, in 2 pages downstream, but I'm going to just capture this and maybe move this note very soon. Operator in training, not qualified, and this will remind me to check. And that was from Exhibit 13. That's the qualifications page. Operator previously warned. Outrigger setup. and overload. So we have some prior information. That was Exhibit 10. And then we have no direct supervision that I could tell. And so I'm going to, at least in this case, this may sound like a guess, but I'm going to at least put it down and put a question mark, no direct supervision. At the bottom of this page, I'm going to put just a little bit, so I'm filling out my investigation form here. I'll just put a note down here, inspection form. And I've got Exhibit 15 that helps me understand I have 2 cracks, and they were monitor and repair. I want to capture it because it's associated with the LHE, and I don't want to forget that there was some items with the crane that might have been in question, and there may be need to go back and review that data or information downstream. What we're going to mark off over here, we have synthetic web slings. I'll mark that off. I'm going to make a mark here and circle the 3, and get the. Then I'm going to come over and then circle the choker hitch. And I already have a drawing. I'm going to note up here 3 web choker hitches. And of course, we'd be typing all this out downstream, but that came from Exhibit 6. And then Sling 1, I'm going to make a note there. Sling 1 had 4960 in a choke. And it was in a rejectable state. I'll make that note as well. And I can have other data that goes along with that. This particular sling, its serial number was 1214166-2-1. And all the other details that go with that particular sling, it's a 2-inch, 2-ply sling, 6,200 in a vertical hitch, and so on. So I can make all those notes by 12 feet. So I would make the notations in that box of all the pertinent data, that of the highest priority information first, followed by my other data as I identify that sling for holding in my report as I go along. Let's take a look at number 2. That sling had a choker hitch of 13,120. Hitch capacity, it was also rejectable. We're going to make that notation. And we have other information. We know that that's 19104021. That was the serial number. And that's a 3-inch, 2-ply. And then we have photos that give its condition. And of course, it was by 12 feet. And then item 3, sling 3. I'll put that up into view here. And item 3, sling 3, was 4,000 pounds in a choker hitch. And that was an EEI 2902, 2-ply sling, 2-inch. It was also in a rejectable state. We're making those notations. I mean, we have to remember everything that we've been looking at and then document downstream all those things that were noted. Also, it was under capacity. And then we get down to load, and what I've done here is I'll make a load equals 13.8. Load factor of about 1.01. Tension should be 46 or so, and that will help remind me, gee, here's our tension as compared to the capacities of the slings in question. So we're tying those back. I realize, appreciate this getting a little messy, but you know, these are new notes for our understanding for how we're evaluating the rigging configuration, the crane setup, crane configuration, the location, and all that. So it's just helping me remind me as I draw up all of the items that are going to be important to us as we prepare a finalized report, what are we trying to note here? What are we trying to evaluate? Let's go on over to the next page. And this is load information. And I'm going to make a notation here that this is it's a steel cutter head. And we have exhibits 5 and 6 that help prepare that information for us, and that's 13,800 pounds suspended load. And here's where I note, I made a note in my report here, load information, and it drags over a little bit. But I did make the note here that we've got 21 feet, and then we've got 9 feet for the rigging, and then we've got that, and the balance to the ground is 20 feet. So it gives me a little bit of understanding of the load height. I'm going to capture that in my report right here along with the load, and basically it's suspension, 3 choker hitches, and no tag line, of course. Make a little note over here. 1 guy operation, so it's hard to run a tag line from the seat of the crane, isn't it? All right, so let's take a look then at page 39. And as I complete my investigation form, yes, I have photographs. And yes, I have some sketches. And then personnel placement. The only person I have here is Jim Swenson that's really an active player in this. And I'm going to make notations here, load path, load travel path, and personnel placement. So that's what this page is really about. So first note I'm going to make is working off rear of machine. And then see Exhibit 4 for that data. And I have a 30-foot radius at 51 foot of boom length, and at approximate 55-degree boom angle. And I've got over the rear capacity. I'm going to make some notes here. I've got load travel path. I'm putting the capacities here because the LHE, this starts to tie the load and the crane together. So over the rear, we've got 12,200 capacity. And if I note here, I got 14,461 divided by 12,200. And I'll share with you where that came from in a minute. That was 1.185. So we're 18.5% over the crane's capacity at that radius. And where that data came from, I just have I compile that gross load information. I'll just put it down here at the bottom. I've got a load equals 13.8. We've got rigging. I've got an equivalent to about 20 pounds of rigging. I've got a block equals 520. And I did add the wire rope in, and that equals about 121 if you take all full lengths of rope all the way to the ground, and we get 14,461 for total load. And that's where I got that number to compare against the crane's load chart. So then we're going to take, so we know that we're overloaded over the rear already, but the crane was able to actually pick it, unfortunately. Then over the side, our information here is 10,200. Let's take that down, and we've got 14,461 again divided by 10,200, and that equals 1.419. So we're almost 42% overloaded when this load is being swung over the side past that outrigger. We go from a 19% overload to a 42% overload, and hence the tip over condition took us, and we were immediately in trouble. I'm going to, in this particular block, I'm going to put in no outrigger blocking or mats, sunken ground. And of course, those are by photo. I'm just kind of capturing where did I get that information. There'd be a question really is out of level, because the out of levelness, we can run a transit and or a 5-way laser and find out, are we out of level? And that's a question that it appeared to be fairly level ground, but what we'd want to do is out of level because we had sunken outrigger floats. The out of levelness will cause that, and I'll go back one page to this page for just a second, just for a little information. If we're out of level here, and we're downhill at all slightly, basically that puts that crane boom at a bit of a greater radius from the machine. So being out of level, particularly towards the downhill, I mean, if we're downhill out of level, we're going to have a longer radius, and it's going to compound everything we're into. And that's why the sunken ground issue is a big deal. Plus, it puts that load at a greater distance from the center of rotation of the crane. So that becomes a point of question, a point of concern for us, and that's why we want to make a note right there. We might want to do some additional evaluation. Let's see. We load swung. This is about load placement, load travel path, and personnel placement. Swung to the operator's right, and then crane tip over. And then basically we have one person, operator, rigger, serving in the same role. One person serving in both capacities. We have no signaling, no signal person, and then we have no taglines. Basically from here he's trained, not qualified. As a note, I don't have anywhere else I'm going to be able to capture that information, so it's right here where I'm going to capture it. Let's take a look then. The last page here is sequence of events. I'm sorry, second to last on this particular item. Second to last is sequence of events. Yes, a lot of these were known by witness accounts, and we have Cletus Riley gave us an account, Bill Urquhart gave us an account, Johnny Scott gave us an account, and Mike Honcho gave us an account. Lance Minion was never actually interviewed, though he was stated as being noted and identified by two different people, but we don't have a witness report from him. So Cletus Riley assigned, the sequence of events was assigned Jimmy Swenson to move the cutter head. And this sort of is a layout of how the events took place, and avoid the sewer line. So I'm going to make notes there, sequence of events. What happened first? First, Jimmy Swenson was assigned to move the cutter head and instructed avoid the sewer lines. And that came from Exhibit 8. Then, so Riley did that. Urquhart, number 2 right here, and I'll keep my numbers sequential. He was not scoped out. That was a visual, and that's a statement from Urquhart. He had to land his load, and he saw getting light on the far side, and then a tip over. And that was from Exhibit 9. Item 3 down here from Johnny Scott. We're continuing to help build this. Saw load swinging. Was there dynamic activity, etc., and out of control? And then he saw Lance Minion running. So no direct supervision. That was from Exhibit 11. And number 4 from Mr. Honcho, this saw setup, saw Jimmy Swenson set up and rig. And then he also saw Lance Minion running. This Minion must have been in pretty good shape, so he's running all over the place. Exhibit 12. And then I have a question, and that sometimes if you put a question into an investigation forms, it may be a personal note. You may want to make it off to the side or on a separate document. But a question that I have throughout all of this right here, why was the load 20 feet off the ground? There was no obstructions. It was a flat ground and flat access avenue going across from the south position to the west position, and there was no real reason to have the load that high. So I just have a question, and if I'm able to go back and do any further interviews or talk to any of the players there or any other operators, was this a company policy to lift it this high on purpose? What's the whole point? And maybe get some understanding of that. If it had been a foot off the ground, it might have been able to just touch the load to the ground quickly and then avoid the turnover. So being that high off the ground, you have almost no ability to recover from the turnover as it occurs. On the last page of our investigation form, we have LHE information here, details, and rigging. And I'm going to note, this is what I've written down here. So this helps me just summarize the information I've gathered so far. So I've got boom length equals 51 feet, and you know I have exhibit numbers for these. I have radius equals about plus or minus 30 feet. I've got boom angle equals about 55 degrees. And then boom point elevation equals about 56 feet. No cribbing or blocking for outriggers. And I've got off the rear, I've got 19% overload. And then over the side, I've got about 42% overload. And what I'm doing is summarizing here in the physical evidence, because that information certainly came from the load chart. I didn't create it out of thin air. Witness accounts for, moving from rear to side. Okay, so those are substantiated. 3 slings were damaged or rejectable in their current state, and 1 was overloaded. So that's an issue that helps speak to the lack of training professionalism or oversight management of the location. Boom unequally telescoped was a physical evidence. 5/8 shiv block or half-inch rope. That's physical evidence, and that again speaks to and this is just a side note for me, lack of professionalism and training. And I'll strike that but that's just so it's highlighted what is the overall perspective of how they manage their yard and how they operate and perform their functions. We know we had a wedge socket was backwards. That speaks to the same issues. And we have an A2B non-functional, actually disconnected. So we have, those are things that I've been able to identify by physical evidence and been able to note. Now, let's take a look then in your document. It's as a different part of our activity here. Let me get you bring up the information here for our root cause analysis on this particular item. This would be on your page 42. And let's note some of and we'll just quickly go through this. Not developed causal factors for policies and programs within the organization. They have no crane and rigging procedure document, no formal training, but what is the recommendation out of this, of course, is develop operator training and qualification program. So within a root cause analysis, we're just taking a hard look at what are the contributing factors and what do you do about it. I mean, if it's all good and well to do an investigation, but we've got to walk away with some fixes. And that's very important for us to be able to manage and function to some fixed point or some point that helps repair what's going on and what's broken in the organization and what do we have to fix. We've noted insufficient planning of tasks, failure to check radius. We were way overloaded no matter what at 30 feet. And then lack of supervision. Swenson was operating without a senior operator there in attendance, and no load weight was not marked or known, but probably to Swenson, he may have thought the load was X. I don't know that I ever saw anywhere that Riley had ever told him how much the load actually was. So the question those were documents in-house, but we don't know if those were ever revealed or divulged to Swenson. But obviously follow the manufacturer's load chart and for all quadrants, needs to operate with oversight, and weight must be known for use of the load chart. And so let's go to the next page. This is just about to finish us out here. And let's take a look here. We have improper equipment attachments, sockets backwards, A to B. That would be a huge question on pre-operational inspection, and that's recommendation to make sure that happens. And then under productivity and schedule, we have co-worker assistant inadequate. You need some help. You can't do everything by yourself. This is very typical for a company to have 6 projects going at one time in the yard and have 6 different guys do them versus 3 pairs of 2 each, where they can actually get it done more efficiently and effectively. So overextending your workforce sometimes, is a huge blowback on ability to do it efficiently and properly. Management needs to enhance their manpower distribution, and that's part of our root cause analysis that we're driving down here, which will be in a summary in just a minute. Deficient orientation or training in proper crane setup and usage, and we really need to hammer home proper training and practices for the organization. Insufficient training follow-up, reinforcement, using crane load chart and being sure that it's set up properly, and that's management's oversight. That really gets back down to they're holding the cards in the company, and they need to enforce and empower their field foremen and their qualified operators to help manage their operations properly. No JHA was completed. There was no documentation of any kind of hazard analysis. They don't use it at Harrington Dredge. We recommend that they would implement starting to use a JHA type process, JTA and JSA. Then let's get down to work behavior. Tools and equipment used improperly, boom sections improperly extended. That gets down to crane setup according to the manufacturer. Co-worker assistance required, not requested. 1 worker to do the rigging, signaling, and operating. And we get down to must have more folks to do the job to do it appropriately and properly. Then unstable ground, no matting for outriggers. Certainly proper matting required as yard policy, and then improper crane setup. Short outriggers, which is a terrible contribution to this. We know that short outrigger on one side, outrigger setup was also a contributing element besides overload, but we're only extended 24 inches on one side, 44 inches on the other side, and we had short footprint, which contributed to this. So we have to make sure that the equipment is always set up appropriately and according to the manufacturer's requirement and load charts. What we've done then is summarize that root cause analysis. Back to that. And management did not ensure proper training, qualification program for operators and riggers. Load weight exceeded crane's capacity at radius. Short outriggers on west side additionally compromised crane's capacity and the crane's capability. And then a lack of crane matting, loss of ground support levelness of crane likely increased radius. Recommended corrective actions, then we have implement a proper training and qualification program, ensure the cranes operated within the manufacturer's specifications and requirements, load chart, outriggers, full extended, telescoping booms equally, and so on. Matting to be used, In this particular yard, I would suspect they have pretty soft ground around there. Ensure cranes inspected prior to use. Develop crane rigging procedures manual for standard and critical lift activities, and then implement a JHA. What we did on the final step here was we included, this is a U.S. type crane accident, and these are all noted violations, and these aren't in your book, but these are all provided sort of the after effect. But we found basically 22 items that are noted here, and some there will be some crossover, but we have, but in the 22, even in rigging equipment for materials, note that we have multiples items within the same category. So there may be actually 40 or 45 total, but there are multiples in each, in a few of these. So ground conditions, inspections, rope inspections, because there's no records, operations of the crane, operator qualification, training, and the use of the rigging they opted for. Then rigging accessories here under the SME B30.5. Also, we got down to noting and quoting from B30.9 for slings down here as well. And Jimmy Swenson was not a trained rigger, so that would be why we'd also draw in the 0.9 plus the violations of the rigging equipment. So these are all noted. We actually have these spoken for in, let's see, the violations. Okay, so these are all noted individually, and so when we stayed up front, I have a large carryover that 1402 in a construction setting, that particular line item, that's the quotation. So you want to detail out your report, identify when you quote from a violations listing that we just did, 1402 and 1412. Those are both noted. Let's take a look at those. And notice that they're the first two line items right here, 1402 and 1412. All we've done is we've taken and been able to expand on those, and those get attached to the report, and they are printed or quoted in full. What does 1402 say? 1412, each shift will do a thorough inspection of the crane, control mechanisms, hoisting system, hooks, latches, wire rope for compliance, and so on. That's when we should have caught that block was not the proper block for that operation. So in each one of these pages, we've got all of these noted as to the infraction, its full detail, and full readout. Each one that's been noted in that root cause analysis, you know, we've been able to then quote, book, and text. What do we mean by that, and where is that indicated? So all the way through clear to the end, sling selection through the ASME B30.9 for slings, effective rigging, or effective environment, and so on. So we don't ever want to quote something just by title here without actually having access to what is the instruction, what is the criteria. Okay, very good. Well, we've been through a good overview. Are there items that could have been caught, could have been discussed, could have been chatted about? Certainly. These are the primary items that we are of most concern about. Jonah, I'm going to have to go ahead and turn it over to you. Looks like I've got a computer screen that just kind of wanted to go gunny sack. Why don't you grab the balance of this, and we can work on the phone with anybody that has questions or concerns.
Sure. Let me take the screen back here. There are a couple questions that we can get to. I know we're running up against it time-wise, so I'll respect everybody's time. We'll just get to a couple of these questions. But some of the other people who have asked questions, I think I can get you an answer offline, so look for an email coming from me. And if anybody else has a question, feel free to email me at jonah@iti.com. So let me grab the screen back here. And one question we do have, Mike, Diego would like to know your recommended do's and don'ts when conducting witness interviews.
Okay. I think the biggest thing, of course, is what you really want to do is to use the old who, what, where, why, and when, and that will lead you to in your interview process. Who did you see? What did you observe operationally, machine-wise, environmentally? Where were you standing? Where was the machine in question, or the rigging activity, the crane activity in question? Who was operating it? Who was where in the yard? And so all you really want to do is go down through the who, what, where, why, when, and how, and it's simply asking questions but providing no leading information. You can't squirrel up the interview process by leading them. Wasn't Jimmy Swinson a bad operator? You don't want to lead like that. That's terrible to try to get some admission out of people that are simply there as account witnesses, and evidence witnesses. So you want to be as very plain-spoken as possible. One thing you do want to do when you have an accident like this is to separate all the players. You want to get them all to different rooms and out of touch with each other, that they can't talk to each other or confer or compile a story with each other. They may be on a rigging crew, maybe in a crane crew, but you want to separate them as fast as possible, get them sequestered to different locations so that they can't come up with some new perspective of how an accident occurred. So separate the witnesses, ask them bare-faced, plain, cold questions, who, what, where, when, and how, and why, and no leading questions that would cause them to arrive at some conclusionary statements versus evidence statements. I hope that helps.
All right, great. And then I think we have time for one more here. Walt was wondering how significant the use of half-inch cable when 5/8 inch is required was, and is the usage of a smaller cable a direct violation of OSHA or ASME?
Okay, excellent question. Actually, what we saw in the load chart was half-inch wire rope was the specified wire rope for this crane. What really, and that's actually what they did have on the crane. What did happen was, though, they used a 5/8 inch sheave block. So they grabbed a block that was slightly larger, and operationally, it won't carry the rope perfectly well down in the bottom of the sheave tread. So basically, they had an overgrown, oversized crane block for this crane. The wire rope itself was actually correct. We wouldn't give it credit any more than, say, 6,000 pounds or 6150 based on the actual construction. But the rope was correct for diameter. What was incorrect was the sheave block. And if they were going to regularly use that block for this crane, they should have selected a block that had half-inch sheaves in it and the appropriate rating for the usage with that particular crane. So that was the mix-up there. Proper rope, improper sheaves for the block in use. I appreciate the question very much. I really appreciate the time with everybody today. I hope that stepping through the process, what we want to do is evaluate the evidence, take a lot of photographs, large, intermediate, and close-ups. Get your measurements done, capture your evidence. Don't let that evidence walk away until everything's been absolutely recorded and captured by photographs or by retention. It may be that we cut up parts of the crane and save it in a storage building or a yard. Certainly save the rigging if that's involved in the accident. Preserve the evidence. Don't let evidence walk off. The worst thing you can have happen is that evidence that's crucial to the decision and determination and the final outcome has actually now been destroyed or is out of control and gone. It's a terrible thing to have, particularly when you have a fatality and or other serious injuries. So capture and retain the evidence. Be quick to get to the accident site as quickly as possible. Segregate the witnesses, get their interviews done, and do the measurements, do the comparisons, evaluations, get the load charts for the crane, et cetera, and/or capacity charts for rigging, and start to decipher that information and draw that down into your accident investigation form, arriving finally at some kind of root cause evaluation, root cause summary, and then what basically the contributing elements to that. So it sounds a little complicated, but step by step, it's fairly simple to go forward and execute. But you want to make a lot of notes and make sure you're making notes of things you haven't seen yet, haven't acquired yet, so that you can get to those quickly if it's not physically in front of you. What might be in the office or facility? Do we have inspection records, maintenance records, training records, all the things that are not out in the field? What in the office do I have to go get to help support the other evidentiary parts of this accident? So I had a great time today, and thank you for letting me share some time with you, and I hope we've got a step closer to our proficiency for accident investigation. This is part of a 2-day course that we do in Woodland at our corporate headquarters. We do a mobile crane accident, a rigging accident, and a forklift accident in a 2-day turn. It's a great time and a lot of fun for everybody, and it really is very involved. So if you're interested in attending, certainly get on the ITI website and take a look at that. Jonah, that's good for me today, and I appreciate and thank you for hosting this. I'll turn it back over to you.
All right, thanks everybody. I'll be really brief. I want to respect your time again. Thanks for joining us. Just as Mike said, if you check my screen right now, you can see you can download the training course catalog. As Mike said, this accident investigation course is offered at our Woodland, Washington facility. And yeah, just go to iti.com if you need any help. Again, I'm available through email. It's jonah@iti.com, and thanks again.